Good afternoon, viewers. Today again we are going to be looking at real and apparent depth in physics. As we all know that one of the phenomenon of refraction is when you place a glass block on printed materials. The printed materials or the written words will appear to be closer to the top of the block than it really is. That phenomenon talks about refraction, and we can talk in terms of real and apparent depth. So today we are looking at the refractive index when it relates to real and apparent depth. And the refractive index of a real and apparent depth is given by the formula real depth over apparent depth. So I have a question. Okay, then we have n, which we use to represent the symbol for refractive index equals to r, the real depth, over the apparent depth, which is capital A. So we have n equals capital R over capital A. So look at, we have a question here. A transparent rectangular block 5.0 meter thick is placed on a black dot. The dot, when viewed from above, is seen 3.0 centimeter from the top of the block. Calculate the refractive index of the material of the block. So the thickness of the rectangular glass block, which is given to us, is the real depth of the block, and which is exactly where the dot is when we look at where the dot is when the glass block is placed there. So solution. So the thickness of the glass block is the real depth, which is that 5.0 meter exactly. So my real depth is 5.0 meters. But immediately the glass block was placed on the black dot, it appeared to be closer to the surface of the glass block, which has shown us that that is the apparent depth. It's just like when you view the surface of a swimming pool or a river, it will appear to become shallower than it really is. Except when you not put your feet, one leg into it, then or 1 foot into it, that is when you know that, oh, this river or this swimming pool is what is deep. So that is talking about the apparent depth, because it's appearing to be shallower when you view it from the surface. So the same thing is happening in this case. So the dot has appeared to be closer to the surface of the glass block, which is not the real depth, but that is the apparent depth. So the apparent depth is 3.0 centimeter, 0.0 meters. Sorry. Let me correct this, is 3.0 meters. Yeah, not centimeters. Apparent depth. That's 3.0 meters. So we are now asked to calculate the refractive index of the material of the block. So we can apply our formula. So refractive index is what we are looking for. The refractive index of the material of the block. We don't have that. So let's use our formula. N equals to capital R over A. So this symbol, though it is not really N, but that's a symbol we use to represent the refractive index, looking like N. And that will be, the real depth is 5.0 meters over 3.0 meters. So therefore, our refractive index will be equal to 5 over 3. So it has no unit, because the unit of your real depth and your apparent depth will cancel out. And if you want to put this in decimal fraction, so 3 in 5, that is 1 point, so that should be around 1.67 if we put that in decimal fraction. So that is the refractive index of the material of the block from the question. Thank you, everyone.